Welcome to this online training session. So my name is Simon Grandin and I'm the Photogrammetric Workflow Specialist here at SimActive. So today the topic of my online training session will be improving your photogrammetric workflow with Correlator 3D 8.6. So as many of you may know, we've just released our latest version of Correlator 3D 8.6. This version also allowed many new features that I will review with you today. So let me introduce you to the agendas of today's webinar. So first of all, we will review the Correlator 3D processing options from the graphical user interface to the scripting mode and how you can get the best result possible with your data. Also, we will talk about new features that we've improved with Correlator 3D version 8.6. So I will talk a bit about processing multispectral data and what's new with the latest version. Handling single image satellite project. That's also a new aspect of our satellite modules. Improving MOSAIC SEAMLINES with DSM. So this for customers who have UAV data and medium format or large format cameras will be really impressed with this new improvement. Also, we'll talk about improving using LiDAR for upgrading your photogrammetric workflow, how you can combine your LiDAR and your imagery together. And finally, I will talk about a few other additional features that are in version 8.6. So here's a bit the workflow of a photogrammetric project with Correlator 3D. So first of all, Correlator 3D has a modular architecture, which means that our software is breaking down into basically three big modules, which consist of the aerial triangulation modules. Then we have the DEM extraction module, and we have also the MOSAIC and ortho creation modules. So with those three modules together, well, we have a complete workflow of photogrammetric project, but we also have some add-ons such as volumetric calculation. We have 3D model generation, feature extraction modules, contour line generation. So those are also add-ons with our software Correlator 3D. So basically, if I review the photogrammetric project workflow, well, the AT module is split up into two processes. So the first process is the type point extraction. So the type point extraction is basically where the software is gonna find common features between all your images to make sure that you have one big block of images that is nicely tied together. This is a crucial part in photogrammetry because it's really at the AT part where all your accuracy assessment will be done, and having a good overlap for your project is also critical to have enough type points and a good reconstruction with your images. Also, if you want to have a better absolute accuracy, you can also use ground control points and checkpoint tagging if you required high accuracy. And then finally, when you've done your type point extraction and you've marked your ground control points, well, you can refine all this solution to have one reconstruction with the bundle adjustment. So the bundle adjustments is where we're going to refine the position of the camera, of the images. We're going to refine the sensor distortion. And at the end, we're going to have one nice solution that fits with your ground control points if you have them. And from this solution, you will be able to extract surface model, terrain model, and also create 3D models and perform ortho rectification. So once your AT is done, you can then jump to the DEM extraction. So first of all, we're going to extract a digital surface model. So everything that you see from your images will be displayed on the raster grid of cells. So you will be able to have kind of a 2.5D model from your images. From this, what we call surface model, we also will be able to extract a terrain model. So a terrain model is basically a representation of the topography where we have removed everything that is not terrain related, such as buildings, cars, trees. So if you want to perform classic ortho, well, you could use your digital terrain information. And also, if you want to know maybe heights of various elements in your project, well, you can use your surface model and your terrain model to derive the heights of maybe of canopy, of buildings, and all sorts of elements. Also, you can edit with our DM editing module. You can edit your surface, either your surface model or your terrain model. And then from the model you will have generated, you can either select the surface or the terrain model to perform the ortho rectification. So we're going to correct for the geographic deformation, the geometric deformation that are occurring during the capture of the images, and we're gonna generate ortho-rectified images. So with those ortho-rectified images, you will be able to create an ortho mosaic from where you could map elements, measure distance directly from your ortho mosaic. All those results can also be shared directly within Cesium, since we have an option to display your output on the cloud. And then once this workflow is done, you can add on maybe a 3D model, you can derive contours, as I said, you can colorize a point cloud, and we have so many other options are available. So now let me show you how this transposes into Correlator 3D. So here is the graphical user interface of Correlator 3D. So as I mentioned before, it's a modular architecture. So we have here our three big modules. So we have the AT modules, then we have our DEM extraction modules, and then we have our ortho and mosaic creation modules. We also have various types here of add-ons, such as the 3D model generation, the feature extraction. We also have the volumetric calculation. And also for people that want to learn photogrammetry, we also have a modules or an automated workflow that's gonna go through all the steps one by one and generate you quickly your output. Also, for people that want to start scripting their own project, if there's more advanced user of Correlator 3D, well, you can also use the automated workflow to directly generate some script. So you can either process this like this, and you will have basically a project script that you can make some modification and launch directly your project either from the Windows command prompt, or you can also go into files and then directly run your script, and all the output will be run from the parameters in the script. The script also can be used to run successfully many projects. So one by one, if you have maybe 3 projects to do overnight, well, you can start your script that contains all your project before leaving work, and then the next morning you come in at work, and then all your 3 projects are processed. Personally, I still prefer the approach of going module by module, because this gives you a lot of confidence with your output, since when you're doing photogrammetric works, it's kind of important to do quality assessment between all your different steps, because the previous step always going to have an impact on the next step you will run in. So it's always good to do a quality assessment before the AT. So if I run the AT module, I will have a solution like this that will be shown. So I have here the white lines that correspond to the different links that the software found between the images. I have here those little green dots, which are my different images. In this case, I can see that the residual error that the software found to do the reconstruction is fairly good. We have under 0.75 pixel, which means that the overall reconstruction will be successful. Also, those little triangles correspond to the ground control points that I had in my project. And then once I did the tie point, well, we can run the bundle adjustment, and in the bundle adjustment, the user has the full capacity to play with the software. So if you have highly accurate exterior orientation, well, you can constrain those orientation You can perform any sensor calibration that you want. So the software is there for either the people that are knowing a bit less about photogrammetry, but it can also be good for someone that really want to get the full control over his data and get the best output possible. Once the AT is done, well, we're generating a PDF report with a summary of your project. So you have here the type points assessment, where that's going to give you it's going to give you a bit of the relative accuracy, how well your project stands together. We have the ground control points assessment. This is basically how well the absolute accuracy fits with your ground control point that you've done. Also, if you're using checkpoints which are not used during the reconstruction, they're there only to validate the overall error triangulation. Well, if you're using checkpoints, you're also going to have a quality assessment here. Then you have a review of the bundle parameters that you've used. So if you're coming back maybe 3 months later and you're not sure what type of parameters you've used, you can always come back in your quality report and you will see every parameters that you've used for your project. We have also a before and after the residual the bundle adjustment. We have an overview of the image adjustment, so how much we're moving the images to get one nice solution together. And then we have the sensor calibration information, and then we have the control points analysis. And so at the end, the quality report is really an accuracy assessment of your project. So you can give this to your customer and say, look, with the images that I have and the ground control points that I have, here's the overall accuracy of the project. So you should it's kind of a accuracy assessment to give to your final to your customers. So once you're happy with your aerial triangulation, well, then you can start to derive any mapping product. So the first product we derived is basically the surface model. So as I mentioned before, the surface model is everything that you see from your images. So by default, the software will generate a surface model at 5 times the ground sample distance of the images, and so. From there, you will have the options also of generating a point cloud or specifying your own resolution of your surface model. So as an output, well, the user will have something like this. So you will be able to see your surface model. So you have here buildings, cars, trees, and then from this you can derive a terrain model. So we have an algorithm that will remove buildings, cars, trees, and all those other elements, and then you will have here a terrain model like this. So in this case, we've kept the stockpile because we still want to use them for the ortho rectification. So again, when you perform the DTM extraction, so the terrain model extraction, the user has the full control over what he wants to remove from his surface model. He can go either in the DEM editing modules to perform manual editing, or you can also draw some polygons like this and use them as an exclusion zone, so the software won't remove anything that are inside those polygons. This can be useful sometimes if you're having a bridge and you want to have a perfectly rectified bridge from on your ortho, but you can draw some exclusion zone around the bridge, and then ortho rectify your images from the terrain model. Then if you're using a terrain or a surface model, you have the choice either for the ortho rectification, you can jump directly within the ortho rectification. So you're gonna have the possibility to generate the ortho and then crop your images. So that's a new function we added in this latest version. So now we offer the possibility to have different crop size from each side of the images. Also, we added the possibility of adding a JPEG compression directly in the ortho, so it's gonna reduce the size on disk of the image of the ortho photos. Sorry for that. And so the images are still going to be stored as a GeoTIFF. And then finally, we have the MOSAIC creation, where basically the software will take all the individual ortho and will generate one seamless mosaic, where you can do your mapping product directly from this from this mosaic. So now let's talk a bit about more technical aspect of the new version, Correlator 3D version 8.6. So processing multispectral imagery. So with our version 8.5, our latest our main release was to add the reflectance calibration, and with the version 8.6, well, we add up many options for this reflectance calibration. So we now are able to integrate many sun sensor for the reflectance of the calibration in your images. So a bit of background on how to process multispectral imagery. Well, when you're going to process your imagery, first of all, you're going to capture the images. And since it's 6 independent small sensor, or either 5, depending on the camera that you have, there's a spatial shift between all of them. So you can see here on the left where we have an images where it's kind of a blurry images because all the sensors are still a bit part away one from each other. So the first step here is to register all those sensors together. So when you're going to do the tie point extraction, the software will perfectly align all those bends and will give you something in the middle. So we can see now that depending on the bend that I will choose, I will be able to generate mapping product directly from this images. Then, depending on your requirements or not, you can also calibrate the reflectance. So what does it mean to calibrate the reflectance? It means that sometime when you're working maybe in forestry or precision agriculture, and you wanna compare your growth of your field, or you want to perform species identification. Well, the light condition really change between one flight to other. So if you want to perform maybe a time analysis, it's a good thing to have a reflectance calibration, because it means that the lightning effect is been taken away from a variable when you're going to analyze your product. So it means that everything has been brought back to the same base. So if you're comparing maybe two NDVI that were calculated from 2 dates, well, if the reflectance is correctly calculated, well, and calibrated, well, the effect of the lightning condition should not have any impact on the value of the NDVI that you will calculate. And also the reflectance can be corrected with two elements. So you can either use the light sensor. So it's a sensor that you maybe put on your drone that will measure the lightning condition and where the sun is regarding the drone, and will save those information within the XML file or the XMP tag of the images. Also, the other aspect that you can use is a reflectance panel. So you can take maybe a panel at the beginning and at the end of your flight, and this will also have an effect on the reflectance calibration. One great thing with Correlator 3D is that we're one of the only software that can integrate both of those sources together to perform the reflectance calibration, and also the panel are used in a temporal way. So there's some sort of a temporal adjustment that is done based on the timestamp of the images. So if the images was taking maybe 50 minutes after the panel was taken, well, the panel is going to have a less impact than if the images will be taking maybe 5 or 10 minutes after, because maybe the lightning condition will change. So really, we have focused to get the best reflectance possible, and this should really improve your timestamps analysis. So if you want to perform time series with multispectral data, well, having a good reflectance is a big key to have consistent results. And so if I show to you how does it look in the software, so basically the workflow of processing multispectral data is really similar than a UAV workflow. The only difference is when you're gonna generate the ortho photos. Well, we can see here the reflectance calculation. In this case, I don't have it since I have an RGB camera, but if you're using maybe a Microsense Altum, Parrot Sequoia, well, you will have here the options to using either the calibration panel, the sun sensor, or both of them. So this it's at the ortho step that you will have the options to choose between either one of them or both of them. And so, yeah. So now the other improvement or feature that we've added to our Correlator 3D version 8.6 is basically the handling of single satellite project. So theoretically, or if we look historically with our software, we technically use a pair of satellite imagery to derive a surface model and to derive all the photogrammetric mapping from this satellite project. Now with this image, we had also the request of why I cannot only orthorectify my satellite images if I have an external DEM from it. So we offer now the possibility of adding creating single images projects. So since the satellite project are kind of a bit different than the typical UAV or aircraft project. So instead of having exterior orientation, well, the position of the satellite and the sensor information, it's defined by what we call the RPC file. So the RPC is basically how or where the satellite is positioned regarding the images that is acquiring. And also the satellite is acquiring push broom imagery. So it's acquiring line per line instead of having maybe kind of a one-shot images with some of the with some cameras for aircraft or UAV data. So now we can offer the possibility only to rectify one RPC with so you can directly ortho-rectify your images from an external DEM. So if you have maybe LiDAR over your area and you have satellite data, you can use your LiDAR to derive some ground control points and then use those ground control points to refine the overall RPC position, and then directly skip the DSM generation, because with one images it's technically not possible to generate a 3D feature because we require two images, but you will still be able to generate ortho photos. And from the ortho photos with the satellite data, you will have the panchromatic data and also the multispectral data, which are two separate images with two different resolution, but when they're ortho-rectified with the same surface model, you can then pen sharp your images and have at the end satellite imagery that is at the resolution of the panchromatic with the spectral band of the multispectral. So at the end, you have maybe something at 30 centimeters resolution with 12 or 16 band, depending on the multispectral version that you have. So what output can be derived from single satellite project? So basically, as I said, there's no the possibility to generate the surface model, but you can derive really accurate and nice ortho that you can use to pen sharp them and perform maybe then NDVI or other such vegetation analysis, because the satellite usually gives a lot more wavelength or spectral band than you can have with maybe some of the multispectral camera that are available on the market these days. Then let's jump back to the aircraft and the UAV side of the photogrammetric project. Another feature that we've improved with Correlator 3D version 8.6 is improving the MOSAIC seamline with a DSM. So this improvement really focus mostly on high megapixel UAV data, which are flown quite high, or even medium and large format users. This will greatly or significantly reduce the edition time. So now when we generate the final mosaic with the different ortho, we can take in account the surface model and the elevation changes to derive our seam lines when we do the mosaic. And this really reduce the occurrence of having maybe a building that might be crossed by a seam line. So now by using here a DSM, we can see now maybe on the left side we can see that the seam line are now crossing the edges or the borders of buildings, which are areas where there's no parallax, which means that both orthos are really tied one with the other one. On the right side, we have here another project where we can still see that the seam line are quite following the roads. And so for the end user, what this means is that with our previous version, maybe a more in-depth seam line editing was necessary, but with our version 8.6, well, this is kind of a game changer where the user can just quickly visualize the seam lines and really reduce his editing for the mosaic. So if you want to use the surface model in your mosaic creation module, let me show you how you can get it done. And so when the first thing is you will generate your surface model, your terrain model, and then when you're gonna perform the mosaic creation, you will have the options here to use a DEM for a seamline obstacle avoidance. So this means that in your project tree, you will have to select the DSM within here. So select your DSM and then start the mosaic creation with the DEM, and this will use the surface model to derive the seam line, or to have a better seamline crossing to reduce your editing time. Also, this is good also for people that are using external DM. So if you're using LiDAR, and so you're doing your ortho your AT process with your LiDAR, then you're using your LiDAR DEM, so your surface or your terrain model. You can use your surface LiDAR model to derive or to help the seamline adjustment if you want to get a better and a finer mosaic with less editing to do. Another element, and this is one of probably my favorites, since the LiDAR and photogrammetric market are growing crazy, and so here we have a new feature where you can use the LiDAR intensity for image registration. These days, a lot of people are flying either LiDAR and photogrammetric data together, so sometimes it can be quite long and hard to perfectly match your LiDAR and your imagery together if you want to use your LiDAR as a reference to perform the ortho rectification, and you want to have nice output layers. So now with our latest version, we offer the possibility of using the LiDAR to create intensity map and digital surface model, so you can use them directly in the software to perform your aerial triangulation. So so instead of taking a pen and a pencil and writing down GCP's coordinates, now everything can be done quickly with Correlator 3D. So how this can be performed is basically you can have your project here. So so you can have your project. You can go into file import LiDAR, and you will have the possibility to add LiDAR last file. So you can directly import your DEM and your intensity, and so this will give you here an example. We have the intensity map, and then we have the DSM. And from there, you will be able also to use our new GCP collection feature. So you will be able to have here the little triangle with the plus button. And so let's say the MOSAIC would be an intensity map. So I would be able to select this feature, and then go here maybe on. I would like to use the corner of this, or maybe I would need to use the corner here. So I would just select it here, and then the software will directly recognize the planimetric coordinates of the reference ortho and the elevation reference from the surface model of your LiDAR. It will create the name of the GCPs, and all you would have to do is probably tag your ground control point. So this really saves you a lot of time when you want to match your LiDAR with your project. And so this can quickly be done like this. And then once you will be ready, you will be able to run your bundle adjustment using ground control points. So it will use the points that you have been collected from your intensity map and your LiDAR DEM, and you will be good. You will be good to go, either to directly run your ortho rectification, because you will use your LiDAR surface model or terrain model, and then it's going to quickly save you some time if you have a large amount of data to process, because it's a good way to see LiDAR and photogrammetric data, a good complement with each other, instead of seeing one is better than the other one. So now you can really integrate and add each strength of each data set within the same software with a simple solution. And then finally, here's a few other feature that we've added with our Correlator 3D 8.6. So as I mentioned, in the ortho rectification, the ortho can be generated with a JPEG compression. So you're gonna have really less impact, a smaller size on disk. The image can now be cropped from each side, so it can be left, right, top, bottom. So you really have when you're working in a sloped environment where you have a strong effect on the slope in your ortho photos, you can select some areas, some side to crop more than the other one. As for the hardware part, well, we can now process project with some Intel GPUs, so recent Intel GPU, and also if you don't have any GPU, we can process your project on the OpenCL CPU. The process is going to be a bit slower, but it's also going to give you the capacity to process data with your computer. So and finally, one of the last tools that we added, which is it's also useful, is in the DM editing module. So let's say if you're loading your terrain model, you can directly specify a rectangle tool, so you can here in the DSM modules. Usually we had the options of having of drawing a polygons, but now if you want to have nicely done area, you can use this to draw perfect rectangle or square. So, and use this to crop your data for final deliveries, or to do some small touch up. So again, this is another new tool, a new feature that we've added with our version 8.6. So now, a bit of unique benefits about Correlator 3D. So we have unmatched processing speed. So we're mostly focused on processing really large data set. We can process many thousands of images on a single PC. You can run. You don't need a superhuman machine to run a large project. Well, we can take advantage of your computer. No training is required. We have a solution that can fit to someone who wants to start to learn photogrammetry, but also someone who knows a lot about photogrammetry and really want to get the full control over his data. Everything is possible from our automated workflow to our modular architecture, where you can go module by module. As I said, we can process unlimited numbers of images on a standard PC, and we can also offer a batch process from script, so you can run your project from Windows command prompt. You can launch your script directly in the GUI interface, and also the software can be installed on some cloud instance. So if you would like to run on AWS on Azure instance, we're there to help you if you want to do so. So we can install Correlator 3D on a cloud-based approach. Also, we offer flexible pricing, so we offer different types of licenses, such as the monthly subscription, yearly subscription, permanent subscription. We have different types of licenses. So UAV goes up to 50 megapixel, medium format, full format, satellite data. So we cover a wide range of sensor. We offer also the node lock or the floating capacity. So if you're working in an office environment where you need a floating license, we're there to help you. And also, we offer free processing for marketing purposes. So you can also write us at sales@simactive.com if you want to have a bit more information. You can download a 14 days free trial from our website, www.simactive.com. Thank you everyone for attending this online training session. My name was Simon Grandin, and I'm the Photogrammetric Workflow Specialist here at SimActive. And I hope you have a great rest of the day.